All right, so today we're taking a look at day 7, which is quadrilaterals, and it shouldn't be polygons, it should be parallelograms. All right, so special type of parallelograms would be stuff like squares, rectangles, rhombuses, trapezoids, which is not a parallelogram but does fall into the quadrilaterals field here. So remember, we have essentially for a parallelogram, we have 6 properties we talked about. We have these 5, so opposite sides are parallel, opposite sides are congruent, opposite angles are congruent or parallel. Consecutive angles, which is the angles next to each other, are going to be supplementary at 180. The diagonals bisect each other, and then the other one we added is kind of a combination of these two, which is one pair of sides is going to be congruent and parallel. So when you're proving a shape is a parallelogram, you just need to make one of these things happen, okay? A rectangle has 2 extra properties. We have 4 right angles, and we have the diagonals that are equal to each other. And a rhombus has 3 extra properties. 4 congruent sides, the diagonals are perpendicular to each other, and the diagonals bisect the angles. And a square has all of that stuff. All right, remember in a trapezoid, only one set of sides is parallel, and that we know with the mid-segment theorem that the median of the trapezoid is parallel and is the average of both of the bases. If it's an isosceles trapezoid, the legs, which are the, we'll draw ourselves a little picture here. If this is an isosceles trapezoid, the legs, which are the 2 non-parallel sides, are going to be equal. And the base angles, which are the angles at the bottom and the top here, are going to be equal to each other. All right? And these 2 sides, which are going to be parallel, are referred to as the bases. So if you draw a line from the midpoint here, which is right in the middle, this is the median, okay, then this line is the average of the top and the bottom. And that's kind of what we talked about yesterday. Okay, so starting off with number 101 off to the right. So key thing we got to hear and identify is what shape do we have? So we have a parallelogram. What else do we know about it? So we have extended a line, okay, and then we have these 2 sides equal. And we also know that R is 124, and we are trying to find angle AFD. Now, angle AFD is the angle that's right here on the top of that triangle. So make sure we're labeling our diagram. That's key here. So we know that these 2 sides are equal, and as soon as I mark these sides equal, that means this triangle is isosceles, and these 2 base angles are also going to be equal. So one idea here to get the measure of this angle AFD at the top is to figure out the base angles and use my triangle. Now, we already know that angle R is 124. So remember here, because we're dealing with the angles of a parallelogram, that the opposite angles, right, are equal to each other. So this 124 is going to be the same as this guy right here. Which means that this angle, which is 124, is going to be the same as this angle. So we know this angle is also 124. Now, since we already were talking about the 2 angles inside the triangle, remember that these angles have to add to 180. So 180 minus 124 is going to be 56. So that makes the measure of these 2 base angles 56 degrees. And then 56 plus 56 is 112. So 180 minus 112 is going to be 68. And that is going to be the answer to that first question. All right. Number 102, right below this one, we have a parallelogram again. Identify what shape you're talking about. Okay, we have a diagonal. One of the diagonals is drawn. These are not both of the diagonals, just TR is. Okay, we have V and R, which are points on TS and RQ. UV intersects at W. Okay, and here's some more information. We have S is 60. SRT is 83. TWU is 35. And we are trying to find the measure of WVQ. So that WVQ is right here. So that's the angle we're trying to find. And then we're going to label everything else. So angle S is 60. SRT, which is this angle right here, is going to be 83. And TWU, which is the angle that's right in here, is going to be 35. Okay. Think about if you have any ideas on how to figure out what the measure of this red angle is. Okay, so hopefully you may have identified the fact that there is a triangle chilling right here. So when these questions, when you're trying to figure out the measures of certain angles, try to look for triangles, try to look for supplementary angles, things along that line. And also, we also know that this entire angle, which is right here, has to be supplementary to this entire angle right here, okay? So the whole thing, the consecutive angles are supplementary is something that we're going to want to use here. So if these angles add to 180 degrees, then 180 minus 60 means that this big angle is 120 degrees. So that means that this angle down here would be 120 minus 83, which is 37. And because we know that these are vertical, that makes this angle also 35. So we have a couple options to get the angle WVQ. Remember, the exterior angle theorem says that the exterior angle is equal to the sum of the other two remote interior angles. So angle WVQ should equal the sum of 35 plus 37, which makes it 72. Or we could use our triangle, okay? We know that 35 plus 37, we already know is 72. So the angle that's right here is 180 minus 72, which is 108. And that would make 180 minus 108 equal to that red angle, which again is 72. All right, number 105 right next door. We have ourselves a parallelogram. We know that the diagonal is drawn. We know M is 118. Angle LNO is 22. And we want to show why angle NLO, which is right here, why is this 40 degrees? All right, so we have 118, we have 22. So there's a couple different things. Number one, when it says explain, that means we need to use words. Okay? So keep in mind, what do we know about this shape? We know that this is part of a triangle, and we also know that the opposite angles are equal. So if we can get this angle to be 118 degrees, then we can use our triangle to figure out that this has to be 40. So for explaining, we can say that angle NLO is 40 degrees since angle O is equal to 118 because the opposite angles in a parallelogram are congruent. And the angles in a triangle add to 180 degrees. So 180 minus the sum of 118 plus 22 is equal to 40. Would be enough. Now, a little bit more work, but you could also use our parallel lines here to get that this angle up here is also 22, and these two angles right next to each other, M and MLO, are supplementary, so this would be 62, and then 62 minus 22, but just another different way to make that happen. All right, let's go back to the right side here at 114. So we have two triangles which are equal. We have the line drawn. We want to know what shape is this quadrilateral. So in order to be a rhombus, remember we need all sides to be equal. We don't have two diagonals drawn, so we can't use perpendicular. The rectangle would need these to be 90-degree angles. Square needs to make all that happen. Now, if we're looking at just these two triangles being congruent, that means that we can start using our CPCTC. So we would know that angle ABAE, where A is, and angle C here are going to be equal, okay? We would also know that this angle where B is and angle D would be equal, and we would know that this angle and this angle are equal. We'd also know that these sides are congruent, So BE and FD, AE and CF, and then BA and CD. So the only thing we have in terms of this shape going around the outside, which I'm going to outline in purple here, is we have two sides equal. That's all we have right now. Okay? There's really no way for me to get anything about these two triangles. We might be able to kind of work it, but the easier thing would be to look at the fact that these two angles are equal. Okay? Angle BAE and DCF. And these angles make a Z. So that means that these two lines have to be parallel. And because they're parallel and congruent, we can say that it is a parallelogram. We're not going to be able to get BC equal to DA. These two triangles, right, are not going to be equal next to each other. So we're going to be stuck with a parallelogram here. All right. Number 107 is missing a little bit of information here. So give me a second. So it should say in quadrilateral BLUE here. All right. BE and UL are congruent. So we should know that already. So we know that these two sides are equal. Now, in order to make it a parallelogram, we don't have any diagonals drawn. We're either going to need to make BL congruent to LU so that these two sides are equal, or we can show that the same two sides are parallel, which is going to be BE parallel to LU. Those are our two options. So we have BL in EU, which is not the same. Also, that would make two sides congruent and the other two sides parallel, which is not going to work. We have LU parallel to BE. This was something we mentioned, so this would be true. And these two down below here are not going to work because they're going to get that there's three sides congruent instead of all four. So we're either going to know that BE is the same as BL, so these three would be the same, or, in number 4, that LU and EU and then BE would all be equal, and we don't know anything about the third or the fourth side, so we're kind of stuck. So it's got to be choice 2, and because we know it had to be one of either these two options, that's the ones that we're going to pick. All right, number 1 right below it. Which statement is always true about parallelograms? The diagonals are congruent is going to be a rectangle. The diagonals bisect each other is for a parallelogram. The diagonals perpendicular is for a rhombus. And the diagonals bisect the angles is also for a rhombus. For the one right below that one, parallelogram must be a rectangle when its diagonals are perpendicular. This is a rhombus. Diagonals are congruent would be true. And the opposite sides parallel and opposite sides congruent is for a parallelogram only. Not enough for a rectangle. All right. Number 125 right below that one. Remember, what shape are we talking about? We're talking about a rhombus. It intersects at this point. And the equation of the line is just going through y equals negative x plus 3. Now, this is a question we've done before. A couple days ago, we talked about equations of the lines. This is going to be perpendicular to a point, okay, essentially not on the line. So perpendicular to a given line through a given point. We're going to kind of do that one. So what we're going to use here is our y minus y1 equals m times x minus x1, our point slope form. This is our point. So this is the point x1, y1, and we know we are going to be perpendicular, okay, to this line because the diagonals in a rhombus are perpendicular, okay? So the slope of the given line here, right, in y equals mx plus b, would be that the slope is negative 1. So the line that we have should have a perpendicular slope, which is the negative reciprocal, so that's positive 1. So if we plug our point in, y minus y1, which is 1, and x minus x1, which is minus 2, and then 1 times this is just going to stay the same. So if we add the 1 to both sides, we're going to get y equals x minus 1. And this would be our answer. Now the other option is this point has to make the line true. So if we plug this in, is 1 equal to 2 minus 1? Yes. If you try to plug in the next line, is 1 equal to 2 minus 3? No, this is negative 1, so that's out. What about 1 equal to negative 2 minus 1? Like this is negative 3. And what about 1 equals negative 2 minus 3? Like that's negative 5. So just by plugging this point in, it has to make the line true, and the only one that works is choice number 1. All right. The last one on this page, remember we have a parallelogram. We have the diagonals being drawn. So there isn't a picture here, so draw one. Okay, draw one. So if we have a parallelogram, and we're going to kind of make it look like a rhombus or a rectangle because it says we need to show that it's a rectangle. Which statement proves it's a rectangle? So let's just start out with something that sort of looks like a rectangle. Now, remember when we label A, B, C, D, we just pick a corner and then go around in a circle labeling those letters. All right, so if the diagonals are drawn, remember that in a rectangle, the diagonals are congruent. So that means that AC should equal BD. That is choice number 1. If AB is this line, and BD is this line, they're not going to make 90 degrees. That'll never happen in a rectangle. AC and BD being perpendicular would make this a rhombus, and AC bisecting angle BCD would also make this a rhombus. So choice number 1 would be the most appropriate here. All right, and I'm just going to highlight these other choices real quick for us. All right, next page. With information, remember, read carefully, not sufficient to prove that we have a parallelogram turning into a square. So remember, squares have all sides equal. Okay, draw yourself a picture. All right, should the diagonals be perpendicular and congruent? Yes, they should. So this would be sufficient. So we would not want to pick number 1. If the diagonals are perpendicular and congruent, that's a square. The diagonals are congruent, and one pair of adjacent sides are congruent. So if the diagonals are congruent, okay, so if they're both congruent and perpendicular, this makes it a rectangle, and this makes it a rhombus. So that means it's a square because it's one of each. And number 2, if the diagonals are congruent, this makes it a rectangle. One pair of adjacent sides congruent also makes it a rhombus because it makes all sides equal. So remember, the opposite sides are already congruent. If we make the adjacent sides congruent, that means that all of them now are equal. Okay, if the diagonals are perpendicular and one pair of adjacent sides are congruent, this is a rhombus, and one pair of adjacent sides congruent is also a rhombus. So this would not make it a square. And the last one, the diagonals perpendicular, is a rhombus. One pair of adjacent sides perpendicular gets me right angles. That is a rectangle. So choice 3 would not be sufficient because it is just the properties of a rhombus. And the last one, draw yourself a picture again. So we have a rhombus. So all sides are going to be equal. So try to draw something that looks like a rhombus. VENU, so just go around in a circle, labeling VENNU. And we have the diagonals drawn. And remember, the diagonals in a rhombus are perpendicular. And they bisect each other because it's a parallelogram. So if VN is 12, that makes each of these 6. Okay, I'm going to label that in a different color just so we can tell the difference here. And then EU is 16, so each of these is 8. We want to know what is the perimeter of the rhombus. So really what we need to do is figure out what are the length of this side right here. Now, if we focus on the fact that we're talking about this triangle, which is the right triangle, we have two sides of 6 and 8 here. So just so we can see a little bit better. 6 and 8. all right, and a right angle, so we can use Pythagorean Theorem to get the length of this, and then all four sides would be equal, so the perimeter would be to multiply that length times 4. All right, so 6 squared plus 8 squared is equal to c squared. This is going to be 36 plus 64, which is 100. And then the square root of 100 is going to give us 10. Now, because 10 is the length of one of the sides, that's not the perimeter. 40 would be, because it's 4 times 10. So just be careful on that one. All right, on to the last two here. So these are coordinate geometry proofs. So remember that we want to identify the shape that we're trying to show. So in our first figure, you can go ahead and graph the lines. Go ahead and pause, graph your points, and draw on your shape. Now, if we want to show it's a rhombus, the easiest way to do this is to show that all the sides are congruent, which means we want to use the distance formula or Pythagorean theorem to get the length of those sides. Because if we just count the rise and the run to get from each point, we're going to get a right triangle, and then the length of this third side is the hypotenuse of that triangle. So if we count how many moves up and to the right, we're going to get 5 and 5. And if we go from T to S, we'll also get the same amount of rise and run, which is 5 and 5. And then going over from AT and then N to S, we're going to get 7 and 1. And you can just count the number of spaces here. So we just need to do the Pythagorean theorem essentially twice, because we have two different length of sides. So if we plug 5 squared plus 5 squared in, this is going to be 25 plus 25, which is 50. And then the square root of 50 is going to be the length of those sides. So we can imagine that this length is the square root of 50, and this length is also the square root of 50. Okay. The other Pythagorean theorem is using 7 and 1. So a squared plus b squared is going to be 1 squared plus 7 squared. This is going to be 1 plus 49, which is also 50. And we take the square root. The square root of 50 is also the length of these sides. So because each of these sides has a length of the square root of 50, we know that they all have to be equal. So we're going to go ahead and make a quick statement about that. We're going to say NA is congruent to the next side, which is AT, which is congruent to the next side going around the corner here at TS, and that's congruent to the next line, which is NS or SM. How do we know that these are equal? Because we just showed that the distances are all the square root of 50. They're all equal. Okay? Now, important thing, we need to make a summary statement. We need to make sure we prove it. So just like our normal proof statement at the end of a proof, we're going to say that NATS is a rhombus, and then we are going to make sure we identify what property we just used. This has just shown that all sides are congruent. So it's a rhombus since all sides are congruent. So in a coordinate geometry proof, okay, key thing. Number one, you're going to use either the slope, distance, or midpoint to show some work, okay, to get sides or angles equal or equal to 90. And then you're going to say something about that work, and then you're going to make a summary statement about your proof in terms of what type of shape it is. All right, going down to the last one here, we want to prove that this is a parallelogram and also a rectangle. So once again, we're going to go ahead and label your shape. So M is the point -4, 2. So that is going to be here. A is -1, -3. T is 9, 3. And H is 6, 8. So make sure when you draw your shape that it actually looks like what you're trying to show. Now, in order for us to show a parallelogram and a rectangle, because we're trying to get a rectangle, we kind of want to make sure that there are all 90-degree angles. In a parallelogram, we can show that the opposite sides are parallel. So we can just use slopes to do both of these things. So we kind of want to tailor the approach to the question to which is going to be kind of like the smallest amount of work. Now you could do congruent and do distances, and then talk about the fact that you have two sides that are perpendicular to make it a rectangle. So we'll kind of go about doing both of these on this question just in case you weren't sure. So let's start with just the slopes. So once again, we're going to go ahead and draw in our rise and the run here, like we did before for the distances. We're going to count 1, 2, 3, 4, 5, and this is over 3. Now with slopes, you just have to make sure you're careful because the direction the line is moving does dictate positive or negative on your slopes. So just be careful. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6. I'm just double checking here. All right, and then 1, 2, 3, 4, 5, 6. All right, and then 1, 2, 3, 4, 5, 6. This is 10. I was wondering why I was getting 5 over 3 and 6 over 9. So that's why I was already identifying that these ratios are going to be the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because I know that like 9 over 6 is 1/3, and this is 5/3, and that doesn't reduce down to the same thing. So that's how I was kind of like questioning what was going on here. So just make sure that we're using the correct numbers. If you get something in your question, okay, over 3 and down 5, where you know it doesn't work, but it's supposed to, you probably counted or graphed wrong. So just double check everything. Okay, so we are going to start by doing the slope. So remember, we're going to do an M, and then we're going to write real small next to it what line we're talking about. This is the slope of MH. Now we went up 6 and right 10. So remember, it's rise over run. So up 6 and over 10 to the right is 6 over 10, which we can reduce down and take a 2 out of both to get 3 over 5. Okay, the next slope that should be parallel to this one is the one down here. We'll call it AT. And once again, this is going down 6 and left 10. So we'll do down 6, negative 6, and left 10, which a negative over a negative is positive, and we can take out a 2 again to get 3/5. So this tells me that these two lines have the same slope, so I know that MH is parallel to AT. Okay, likewise, if we do the slope of MA, now I'm going down and right. So the rise would be -5, and the run is 3, okay? And this is the slope of MA, or AM, and then the slope of HT, and you can see this is going to be right 3 and down 5. So once again, the rise is -5 and the run is 3. And we can see that these two lines are also going to be parallel. So AM is parallel to HT. Get a total hat on these guys. And how do we know that? Because the slopes are equal. Okay, now we also know, so this is enough right now to say that this is a parallelogram. Okay, so we can say MATH is a parallelogram. And what did we just show? We showed that these two pairs of sides, these opposite sides, are parallel. So since opposite sides are parallel. Okay, now we also want to show it's a rectangle. So what do we now know? Well, we know that MH and AM are perpendicular because they are opposite reciprocals. Okay, so MH is perpendicular to AM. All right, we also know that MA and AT are perpendicular. Now, we don't need to get all of these. We just need one of them. But you can kind of fill in from here that AT is perpendicular to HT and that HT is perpendicular to MH. Okay, so we have 4 sets of lines that are perpendicular. How do we know, once again? Because the slopes are opposite reciprocals. All right, and that means that MATH is a rectangle okay, since all the angles are 90 degrees. And why? Because the lines are perpendicular. That's it. So that's how we're going to go about getting a rhombus, a rectangle, and a parallelogram. Square, you just need to show that you have either all the sides perpendicular with 2 sides that are next to each other being equal, or all the sides equal with 1 set of sides next to each other being perpendicular, making a 90-degree angle. And that's it for today. Hope that helped out. We'll see you tomorrow for day 8.